Hello, hello, hello. Hello, hello to those who are here. Hello, 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 hello. Let's do this. MXD Raptor, what's that? Okay. Alright, good night, good evening, good afternoon, good everything. Good eight everything. So let's see, we've got Faran, Kabdi, Risak, we've got It's Boy Tumelo, we've got Angel, we've got Nduduzo, Spesihle. Oh wow, hello Lesejo. Long time. Yo, 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 yo. Alright, Lesejo, you grade 9s. I'll be getting you guys into the mix, let's say sometime. Let's see if we can't get tomorrow night. I think I'm gonna give the grade 10s a break tomorrow night, eh? Funny thing is, I was thinking about the grade 9s today. Because Chris, this upcoming term, we've got your guys' geometry coming up, and I think it would be sweet if we could start it early, right? But yeah, unfortunately today it's not grade 9 that I'm about, it's grade 10. But it's good seeing you, Lesejo. Hopefully the term went well. Hopefully the term went well. So yeah, I'm continuing with grade 10s, the grade 11s and the grade 12s. I'm just continuing on with the probability, and I'm going to be doing some grade 10 basic stuff there for your probability. So we basically, session 4, we've done session 1 of probability with the grade 10s, 11s and 12s, and basically I've said that for all grades, grade 10, 11 and 12, this is beneficial, right? So we'll be continuing on from where I left off from yesterday. And guys, if you want to check out what we've been doing for the past 3 sessions, please go to my YouTube channel. The probability sessions that we've done, the 3 that we've done so far, I've already uploaded the videos. They are long, they are full of goodness and meat. They are meaty, they are meaty. They are full of info. I think anyone who wants to get probability off the ground, like the basics, you can check out those videos. I think they are worth it. They are worth the time, and they are worth the energy that was put and the effort that was put in there. So today we'll be looking at the general rules of probability from grade 10, okay? And we'll be focusing primarily on the Venn diagram. Yesterday we established what a Venn diagram is, and I think it was Landiwe yesterday that made an example of a Venn diagram being like Lego blocks. Or at least that's what she envisioned when she looks at a Venn diagram. She was like, I see Lego blocks. And so yesterday we kind of had it down that your Venn diagram, since we've got a triangle, we've got circles within, then we may as well fly with the whole Lego blocks concept. So I'm gonna pick it up from yesterday's lesson. Yesterday's session was really, really good, guys. We looked at the general rules of probability yesterday. All right. We looked at the definition of probability. We looked at the general rules, specifically the addition rule of probability. All right. We explained that. We looked at the complementary rule. We explained what that was. All right. Okay, can you guys hang on a sec? All right, I'm back again. Sorry, guys. So, as I was saying from the top, I was saying that yesterday, this is what we looked at. We looked at the addition rule. We looked at the complementary rule. We looked at the different types of events that we find, specifically the mutually exclusive events. We explained what those were. We then looked at Venn diagrams. We specifically looked at Venn diagrams and how Venn diagrams help us to be able to understand these events. Mutually exclusive, we looked at exhaustive events, and then we looked at complementary events. So that's basically what the previous video, part 3 of the lesson on probability covers. So if you guys go on to, like I said, the YouTube channel, and you watch the entire part 3 of the video, it explains all of this. I'm not going to go into it today. What I explained in the previous sessions, I think you can go to the YouTube channel, as I said, and you can check that out during that time. Okay, so today we are going to look at Venn diagrams, and specifically certain things about the Venn diagram. So I'm going to take it one step at a time. We're going to look at this. So we're going to incorporate the general rules from grade 10. Now something to note here. Too much noise. So Venn diagrams, okay, are useful for solving problems. Okay, Venn diagrams are useful for solving problems. Okay, now these words are very important: and, or, not. Okay, and, or, and not. Very important words, these ones, when it comes to probability, because they have meaning. They have they carry meaning, they carry weight. And I think yesterday when we were exposed to the word and actually refers to the intersection. Okay, intersection. All right, and by that we mean what is common. Okay, so that's and there's a symbol that seems to be very prevalent for the word and that is an upside down U. All right, so symbolically and can be represented with an upside down U, and it refers to the intersection. That's what and means in probability. Something that is common, right? The intersection represented by this symbol, the upside down U. Or, on the other hand, means the union, all right? And if we're talking about the union, it's like we are talking about the sum, everything together, the addition of things, all right? And the symbol that we use for or is a U, all right? Then last but not least, not. Okay, not is what we refer to as the complement. Okay, the complement. So not that thing, not, we are excluding that thing, we are talking about something else. So if we are saying not you, it means everybody else. All right, yeah. So not is excluding certain things, including other things. So that's very important to note. Okay, so in our Venn diagrams, these words will help us to be able to identify certain aspects in our Venn diagram, right? for specific events. So let us look at the following Venn diagrams, and with that I want us to turn our attention to the Venn diagram number 1. Okay, so if I say to you A and not B, A and not B, remember A will represent event A, right? And remember, event A can also mean the set A, all right? We kind of use those words interchangeably. So A is this circle. It's the event A, also referred to as set. We could say it's the set, right? And if an event will contain elements, all right, it will contain certain elements, or we can say a set will contain certain elements, right? So event A, and this is event B. Now we want to identify, when we say A and not B, what are we speaking specifically about? Which region or area are we referring to here for the diagram? Okay, and I'm sure you guys can see that I've said here AKA. Now AKA means also known as only A, right? So let us see how it is that we actually are able to get to the fact that it is only A. So here is the specific identification or region that we want to look at. What is A and not B? So let us one by one identify what we have here. So when we say A, we mean event A. In our Venn diagram, what is event A? Event A refers to the entire circle. The entire circle of A, all right? And if I was to maybe, let's say, use ticks to identify that, I mean this part and this part. Does that make sense, guys? What I've ticked here is A. This is A in its entirety, right? Then let's forget about and for now. Let's go to not B. What does not B mean? If we are saying not B, in our Venn diagram, what area are we identifying? Okay, so remember, this is B. This entire circle represents B. If we say not B, it means we are not including B. Very good. So that means this part and the part that is outside, all right, as well, because this here and that there represent not B. Are we together, guys, so far? So let me just go back and back up a little bit here. I want to start again. Remember, we are trying to identify in our Venn diagram what is A and not B. So we start at identifying A. What is A or event A? Event A represents the entire circle, set, or event A. Are we together? So I tick this part and I tick that part. That's event A. Done and dusted. I'm finished. I move on. What is not B? Not B means not including B, meaning everything outside of the event B. So when I tick, I am ticking this region and I'm ticking that region. Now, we have identified A and we have identified not B. Now, let us bring it together. When we say A and not B, what does this word and mean? Do we still remember what and means? And means the intersection. So in other words, we are looking for where A and not B intersect. And guys, I'm sure you can see where that is. And maybe to even explain it further, we are looking for where things are common for what? For A and not B. So where can you say things are common? They are common where exactly? Look at the ticks. Remember, I made a tick for A and I made a tick for not B. Now you should check where are my ticks common. Because remember, I ticked twice for A and I ticked twice for not B. Now I should go to my diagram and should be able to see, oh, there is a place where for both where I ticked there is commonality. There is an intersection. And guys, can you see where the intersection is? I'm going to shade using a yellow marker where the intersection actually is. Do you guys see that? That is where A and not B actually are. All right. And that's why we say A and not B simply mean what? Only A. A only. So only A or A only. Because it represents this region alone. All right. It does not include this part. So therefore we say this here is A only. That is our answer. When we say A and not B, we are actually speaking about this yellow region that I have just identified. Okay. Can I move on? Are we together? Are we on the same page? Just need an indication in the comment section that we are all on the same page. So please guys, when we say A, we mean the set A, the circle, all of it, the event A. So I am ticking this part and I'm ticking that part. When we say not B, it means not the circle B. In other words, we are going to tick this out, this part and the part outside the two events. Then ultimately, what do we mean by A and not B? We need to look specifically now where we've ticked the intersection. Where is the intersection, guys? The intersection simply is where I have two ticks. In other words, where there's an intersection, where it is common. My common ticks are there. So therefore we highlight this part. That's why we say A and not B is simply what? A only. All right. So I hope so far me and you, we are together. Okay, let me take this. This should be interesting. Academy of Moms.
Yes, sir. How are you?
I'm doing very well, Academy of Moms, and you?
I'm doing well. I'm interested in your lesson.
You are interested in my lesson. What about it? What are you interested in? Say.
Yes, the way you unpack it in terms of you using checking and all this stuff. Because many learners they have serious challenges when it comes to Venn diagrams.
Yeah. That's very true. That's very true. So I was just, and I still obviously in the beginning of this, just trying to unpack it for the learners so that they can find ease in being able to answer questions eventually. So I was just still really at the beginning of this, just explaining the word and, explaining the word or and not, and what it practically means when they are referring to the Venn diagram. So yeah, I was really just still at the foundation and hoping
No
that
problem. I'm following, sir. Don't worry.
I can see my say here is also I see the academy, the MAMS. Maybe just before I continue, care to share more?
No, it's based in Mpumalanga Mkhuhlu. So that is Mkhuhlu Academy of Maths and Science.
Oh wow, okay. Yes, we're listening, sir, because there's learners that are here.
Yeah, no, don't worry. If there is a need that I can intervene, then I will do so. But up to so far, I'm happy. You are doing
Okay.
it very well.
Okay,
Yes.
sir.
If
All right.
there's a need, then I will intervene.
All right. No, thank
Yes.
you. I appreciate you coming through.
You are welcome, sir.
Sure.
Yeah.
All right. So, okay, my learners, let's continue. Thank you so much for that. So now we are moving on to this second diagram here. All right. So hopefully you can see here as well. So we have another nice Venn diagram there, and we have another scenario here. Okay, we have not A and B. All right, not A and B. So like I did in the first, diagram, what we want to do is we want to first identify this here, what it means for the Venn diagram. Not A. Not A refers to which part on our Venn diagram? The not A part. What area of the Venn diagram does not A refer to? Remember, this is A. Okay, this circle here represents event A. So the minute we say not A, we mean not event A. So we can use our pen and we can tick what do we mean by not A. Not A means exactly on event B, specifically at B only, right? We're obviously not going to tick this part because this is still A, all of it here. All right. So when we say not A, it means this part and it also means this part. All right. So those are the parts that we identify as not A. Okay. And I hope that's clear for us, the identification of not A. Then for now, we will just put and on hold and we'll go to B. Remember, when we say B, we mean event B. And by event B, which part of the Venn diagram are we referring to? Okay. Event B means what specifically? All right. We are still going to be ticking this region, but also we are also ticking this region. Okay. Because this entire circle here represents B. All right. That's very important. So now we can come to our end. We said and means what exactly? Because remember, not A, we've identified. B, we've identified. Now we want to find the intersection between not A with B. So what is the intersection? Or in other words, where are we common? We are common here in this area or space. All right. And this area and space, we refer to it as being B only. So once again, I am going to use my what? My yellow highlighter here so that we can highlight the region that we are referring to in our Venn diagram. So this here is what we refer to as not A and B. It is this region. The intersection of not A and B is that region where we are common. All right, the common ticks, or we can say where the intersection is evident between not A with B. Okay, so that's why we can also say that that is actually referred to this area. We say it is actually B only. B only. All right. And that's very important to note. And remember, this one, we had said this one was A only. All right. So say as you use ticks, where there are more ticks, does it give you a hint of that? Yes, because we are referring to two events. And as we are ticking, what are we doing? We are identifying for not A. Remember, when we identified for not A, we ticked this part. and then we ticked outside the two events. And we were done with not A. And we can see where the ticks are, right? Then we went to B. And for event B, we ticked where? We ticked here, and then we ticked there. Now, what are we looking for when we say and? We are referring to the intersection, but this intersection is for not A and B. In other words, where it is common. So where is it common? We are common because the ticks, we had ticked twice, if you remember. This is exactly where we are common. So that is our identification of the answer that we are looking for when we are referring to not A and B. It is actually B only, and that is how we can identify it. Okay. So Landiwa, thank you so much there. I can see in the comment section, and I'm happy that you were able to ask that question there for clarification. Thank you so much. Right. So we can move on to this scenario. Let's look at this one as well. So this is simply a method, guys. All right. This is just a way for us to be able to identify what is the meaning when they say these things. So by using the ticks, it helps us to be able to just get straight to the answer. All right. So that our identification is accurate. So this is just one way. All right. This is not the only way, but this is one of the ways that we can effectively be able to identify, the specific region that they are referring to, okay, in our Venn diagram. So let's look at this scenario. Scenario number 3. We have not A and we have not B. Not A and not B. So once again, we know ultimately we are going to be looking at the intersection. Okay, but let's look at not A. What is not A? Where is our not A? Obviously, when we say not A, it means everything that is not A. In other words, everything that is outside this circle. So let's go and tick everything that's outside this circle. We are ticking there and we are ticking there. Not A, we are done. Let us change now the channel and go to not B. Yeah. So Landio, I like what you are saying. So we specifically say, if you are ticking this part, remember we have actually specifically said that this part is what we call B only. All right. So it's like the event B only. Right. Remember, event B in and of itself is the entire circle. But the moment we just identify this yellow part, we call that B only. All right. Because it does not have this specific part which we refer to as the intersection between A and B. Okay. So we refer to this as event B only. Okay. So not A, we ticked there and we ticked there. Now let's come here. What about not B? What is not B? Okay, that means everything that is outside the circle, what? B. So let's go and tick that. We are going to be ticking here at A only, and we are going to be ticking, in actual fact, outside the two circles, which is like we are ticking there, Moss, because that's outside the two circles. Right? So we've done the identification of not A. We've done the identification of not B. Now, what does and mean? And means the intersection where we are common. So guys, where are we common? We are actually common outside. We are common outside the two events. All right? Outside the two events. So that means our answer lies outside the two circles. And outside the two circles, what is this exactly? This is like us saying this is not A or B. This is not, remember, not what? Not the union. Or if you remember, guys, or means the union of A with B. So that is basically not the union. We are outside the two what? The two circles. Okay, and that's very, very important to note that we are actually dealing with this region of our Venn diagram. It is not A, not B, and the intersection simply lies outside the two events. Okay, thank you so much for that. All right. So if I was highlighting, or if I was shading, this is what we would be shading. All right. This is what we would be identifying. This beautiful space. That is a representation of not A and not B. Okay. 3 more examples or 3 more scenarios to look at. So all of these 3 scenarios were dealing with the intersection. Okay. Now we are going to change the situation a little bit here. And we are going to look at 1, 2, 3. So let's look at the first one. All right. This first scenario is saying A or, right? So we must remember the word or. What does it mean again? The word or means the union. Okay. So it's like everything we have together, you know, like when 2 people are married, especially if they are married in community of property, it's like everything we have together. We are all in this together. Okay. The union, the sum total of what we have together, right? So A or not B. So the word or means union. All right. It is not this time the intersection, but the union, everything we have together. So let's first and foremost go and identify. When we say A, what do we mean? Event A. Remember, event A simply means this part and that part. That is event A. The entire circle, all right? The entire circle of A. The entire set, okay? Then, what about not B? What is not B? Not B means everything outside the circle or the event B. So what do we tick? We tick that and that. Okay. And then this is the word or. Or A or not B. Okay, so that means, guys, we are no longer looking at the intersection. We are looking at the union. In other words, the sum, everything we have together. So everything we have together is all parts that have been identified. All parts that have been identified. That means you get some. You get some. And in actual fact, even the outside gets a piece of the action, the piece of the drama, the piece of the goodness, the piece of everything there is to offer. Because A or not B, we are talking now not about the what is common, but we're talking about the union, everything that has been identified. Okay. We are uniting everything that has been identified. Okay.
Hello, sir.
So I hope. Hello, sir. Hello. Hello, moms. I can't hear you there. Hello.
Yes, sir.
Yes.
Sir, I want to. So sorry. I'm learning also. I just want to check something. Is there? I mean, is it possible to use the additional formula to answer this question specifically?
The additional formula. Yes. But yeah. No, definitely you can.
Our network is poor. I
No.
can't.
Okay. So, sir, here, like I said, I'm still at the foundational sort of like beginning stages of trying to unpack what the A, the not
Yo,
B, the O means for the
I can't
diagram.
hear anything here. It's fine. Just continue. If the network is okay, I will ask this question again.
Okay. Yeah, sorry there. I think yeah, because it's making it also lag with the communication there. Otherwise, yeah. So guys, like I said, what I'm doing right now is something that is just there for the purpose of identification. Okay. When it comes to the rules and so forth, we're going to look at that. But for now, okay, my primary focus here is to be able to have a basic sort of like a street understanding of and, or, and not. Then be able to apply it in our Venn diagram. And then be able to identify the regions that they are referring to when they say event A and not B. So here, I'm not interested yet in the rules. We are going to get there. But for now, I need learners to be able to see how they are able to identify these specific events just merely by reading what does it mean when they are saying A. We know that's event A. We tick the circle of A. Not B, what is not B? Then we simply tick not B. And then what does and mean? The intersection. So where we, like I said, where it's common, so we know that, oh, where we are common is at A only. That is what we were meaning when we were saying A and not B. So for now, this is just a way of identifying the region so that we can be able to get to the answer of what they mean when they say A and not B. Okay. We are getting to the place where we'll be utilizing the addition rule to be able to work out the probability. I'm not even dealing right now with the probability. I'm simply looking at how do we interpret event A from the Venn diagram? How do we interpret what not B is from the Venn diagram? And what does the word and mean as it applies to what we have identified here in the Venn diagram so that we know the area that we are referring to. And then that will facilitate ease in us being able to answer questions. So for now, guys, let's just hold our horses. We will get to all these other places, but I need you guys to just be patient. Let us get through this process, and then we will get to the place that we all need to get to. But there needs to be this basic conceptual understanding of just this for now. We will get to the rules. We will get to the application of the rules and all these amazing things. And I'm thinking that you guys will be able to even understand the application of the rules even that much more. And then also be able to use Venn diagrams to answer questions. So we are getting there. But for now, okay, I hope those who have been with me, you saw what we meant by the first Venn diagram, the scenario that was there, and how we identified this yellow region as our answer. The second scenario, not A and B, how we were able to identify not A being the place where it's outside the circle A, because not A means not the circle A, so that's this part and that part. B means this part and that part, and then and means the intersection where we are common and meet, and that's the area of our answer. What not A and not B means. Not A means not the circle, so that means this part and that part. Okay. And then what does not B mean? Not B means not the circle B, which means that part and also this part outside the two circles, then end the intersection. So that is basically our region. That's why we have actually colored it yellow. Okay. Yeah. So I'm sorry to the people. You see, I think there's different people with different thought processes, but there's a development that I am with, because obviously there is an intended outcome that I want to actually move towards. So I'm going to have to say to those people that have other things they'd like to say, and maybe a direction that they would want me to move in. Guys, you're going to have to hold your horses. Allow me to actually explain to those who don't know. And then I would also encourage you to use the platforms that you have to be able to push the mission that you individually have. That's also very important. Okay, so let's come here. Okay, so for now, guys, Peladi, do I offer one-on-one? Yes, I do. You can just send me a message just in the inbox. I'll get back to you. All right. Okay, so here, let's come here. So now we are, yes, I'll be doing that. We'll be posting this, obviously, as always. Okay. Okay, so we have A now. Okay, I want to come back here. A means event A. So let's just say, if we're saying A or event A, we just mean the circle A. So everything inside the circle A. So that's why when I say event A, I am ticking here and there, because those two ticks represent my circle. Okay, so A, done. Not B means not the circle that is B. So that means we are going to tick outside the circle that's not B, and then even here as well. All right. Then the word or, because we want A or not B. Remember, the word or, as I explained earlier on, simply means the union. Everything we have together. In other words, the sum of everything we have. So we identify the regions that have been identified, because that's everything we have. So that's why you find me shading this part, because there's a tick. Shading this part because there's also a tick here as well, and then also I'm shading the outside part with yellow as well, because there's a tick that has been identified outside the two events. But this part remains white. Why? Because it has not been identified. It is not part of the union. So that's why we only shade the parts that are part of the union. This part deserves to be shaded, that part and that part, because it is the union of these two things. A, we had tick, tick, not B. We said tick, then tick here. So therefore, that's why we have that area being shaded in yellow. That is what we mean by A or not B. The yellow parts. The yellow parts. Okay. Let's come here. Not A. What is not A? Let us go and tick. Not A means not the circle A. Not the circle A. So we're not going to tick inside the circle of A. Not A means this part and that part. B only and outside the two events. That's not A. So we are done with not A. Now let's go to B. Event B. Event B means the entire circle of B. So what do we then do? We tick here and we tick again at B only. All right. Then we have the word or. What does the word or mean? It means the union. In other words, all things together that have been identified. all things together. So here I go again. This is the answer. This is the answer. Because that is what has been identified. It is the union. Everything we have together. All right? Everything we have together. And you can see where there's no white, it means, you are not part of us, you. You are not part of us. You are not part of us. All right? Okay. Let's go to this last scenario so that we can wrap this up. This one says, not A or not B. So let's go first and say not A. What does not A mean? It means not the circle A. So let's tick. This is not the circle A. This is not the circle A. So here we are done with not A. Let's move on to not B. What does not B mean? It means not the circle B. So let's go and tick what's not the circle B. This is not the circle B. This is not the circle B. Then, or. What does the word or mean? It means the union. Or means the union. What does union mean? It means what we have together. Everything we share together. We are married. We are united. It's in community of property. So we share everything, you know. What's mine is yours and what's yours is mine type deal. So therefore, what are we identifying here? Everything we have together. A only, B only. Okay? And then everything else as well. Which I'm sure you can see. Everything that is outside the two circles. That is the addition. Okay, we add everything that has been identified. Okay. Stivovo, you have just Stivovoed in just now, hey? All right, so, okay, I'm going to do that for you, Stivov. Okay, I'm going to do that now for you, Stivov. So I'm sure you guys, you guys can then see the identification. Okay, Jenny Lee is saying, I don't understand him now. The question is, Jenny Lee, at what point did you come into the live? Did you come in smack bang at the beginning when I was actually explaining, or did you just come in midway? Okay, so, all right. So once again, not A. Everything that is not A. In other words, everything that is not the circle A. All right. So I did then tick there and there. All right. Because everything that's not the circle, we tick here, we tick there. All right. Then not B, everything that's not the circle B. So we ticked where? We ticked there and we ticked there. Then what does the word or mean? The word or means the union. Everything we have together, right? So that's why, guys, I explained these descriptors at the beginning of the session, all right? So in our Venn diagram, whenever we are actually dealing with the relationship between events, the word and means what? It means the intersection. That's what the word and means. Okay, and means intersection. In other words, what's common? What is common? All right? And this upside down U is what we use for the symbol that basically describes the word and, which is the intersection. Then we have the word or. Or means the union. Okay? Right? And I tend to say it's the sum, because the sum total of what we have, we add everything we have that has been identified. The symbol we use is U for union, all right? And then not. Not is what we refer to as the complement, right? Not basically is saying, if I say I love my wife and not you, it means it's my wife only, okay? Yeah. If I say not everyone else, then everybody else is not included, all right? Yeah. So it's very important. Not will be able to actually exclude, not excludes certain things or certain areas, okay? So then we come here, all right? Please, guys, now I'm just going to re-explain this for those who came in midway so that we can actually have a common understanding. So let us look at this relationship of event A, because this is A, but it stands for event A, and not B. Okay, so event A, let us identify what event A is in the Venn diagram. So in the Venn diagram, when we say event A, we mean the set A. In other words, the circle A. All right, maybe if I can be more specific, this is the circle, the entire circle of A. So when I say event A, I mean this circle, the circle set, everything that is within that circle. So that is why when I say event A, I'm going to tick once in this part, and I'm going to tick once in this part. Okay. All right. Then I go to not B. What is not B? Not B simply means the following. Not B means if this is B, then not B means everything that is outside of the circle B. I hope you understand that. Not B means not the circle B, not the event B. Okay? Okay? Not the circle B, not the event B. So when I come here, I come and tick there and there. Okay? Then I come to this word and. When I compare what I have ticked for the two events, what am I actually now wanting to identify when I say and between the two events, A and not B? I want what is the intersection. The intersection is where things are common. So where are the ticks common? They are common in this space. All right? This is where the two ticks are. And that is A only. A only. So that's why you have my yellow shading this region alone. Because that is the identification of A and not B. Okay. Can I move on to the next diagram? Are we in the same page, or do we not understand? Okay, I need even the people that were saying. So we're on the same page, Jenny Lee, we're good. Okay, let's say he's saying okay, Jenny is saying good. Okay, Jenny, you actually saying it's good, then I'm good. Steve Ovo still here, because Steve Ovo is also saying that I hope we are in the same page here. Let's look at number 2 now. Number 2 says not A and B. Not A and B. So once again, what do we mean by not A? We mean not the circle A, not the event A, not the set A. You see, I'm using a few words here to explain the same thing. Not the circle A, not the event A, not the set A. So where do I tick? I tick there and I tick there, because that's everything that's not A. Then I go to the next event, event B. What is event B? Event B is simply this part, all right, and that part. This entire circle is event B. Then, what does the word and mean? The word and means the intersection. In other words, where things are common. Where my ticks are common. So where are they common? There, guys. That's why this yellow area has been shaded. Because this description of the relationship between not A and B is simply indicated by this yellow region there. Let's move on to the next part. Not A and not B. What is not A? So not A means not the circle A. So where am I ticking? I'm going to tick here and there. Then after I'm done with that, I'm going to go to not B. What is not B? Not B means not the circle B. So that means this part and also this outside part, which is basically the repetition in the outside of the two events. And then what does and mean? And means the intersection, where we are common. And where are we common? We are common outside the two events. So this is the region that we are actually referring to. Okay. Are we now together, guys, for 1, 2, and 1, 2, and 3? For and the intersection. Because that's very important that we are together, everyone. Okay. All right. Masi move to the last 3. So these ones, unlike the first 3, don't have and, they have or. Now the word or, the descriptor or, means union. In other words, the sum, everything we have together. So let's come here. When I say event A, what am I actually referring to? The circle A. So I tick here and I tick there. What is not B? Not B means everything that's not the circle B. So where do I tick? I tick there and I tick there. The word or means the union. What is the union? The union simply means everything we share together. So I shade here, I shade there, and I shade external to the two circles. Yes, Lerado, I will. Just as I've posted all the other videos on probability so far on the YouTube channel. Link in my bio. You can actually go there and check it out. So yes, guys, there it is. Okay. Hopefully we are flowing and feeling and reeling and sealing and dealing and wheeling and killing the maths, and the identification is coming on very nicely. So let's come to this scenario, not A or B. Not A means not the circle A. So what's not the circle A? We are here and we are there. Then B. What is event B? It means the circle B. So that's there and there. But what does the word or mean? Or means everything we have together. So I shade here, I shade there, and I shade outside the two events. All right. Okay. Then this rectangle, guys, the last one, not A or not B. So we're still dealing with union here. Not A means not the circle A. So I tick there and I tick there. Not B. Not B means not the circle B. So I tick there and I tick there. What does the word or mean? It means the union, everything we have together. So that means I shade you, I shade you, I shade you, and it's like many shades of yellow. All right. Okay, I'm just trying to count the shades of yellow that we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Many shades of yellow. All right. Okay. So I hope now we are appreciating the use of these words: and, intersection, common, or, union, some, everything we have. Not that. Okay. So all of this, very, very important. Very important. Now I want to actually move away from this, because this here is a skill that is useful. What I've just done with you guys is a skill that is very useful in being able to answer certain questions on probability. This here, what I've just done with you, is a skill that you can utilize when answering some probability questions. All right. And I'm going to show you, when I get into some probability type questions, how do we utilize the skill that I've just shown you to answer those questions. Now let's move. When using Venn diagrams, we must always start at the intersection when using Venn diagrams, and we can move out. All right. Especially even when drawing Venn diagrams. All right. So let's look at an example. It's time now we move on to a nice example so that we can start utilizing all the knowledge that we've gained. The knowledge that we have gained when it comes to the rules, the knowledge that we have gained when it comes to the events that we've learned about. And guys, those who are maybe joining in for the first time in my live lesson, you guys are more than welcome to check out the lessons that I've done. I've done 3 sessions already. 3 parts are already uploaded onto my YouTube channel, where I did the beginning of the introduction of probability for grade 10 learners, introducing what probability is, the concept, so that you guys can understand it from the basic root level, and answering basic exercise questions on probability. Okay. Then yesterday we dived into the various events that we have where probability is concerned. Where our Venn diagram is concerned, we looked at many types of different events: exhaustive events, mutually exclusive events, complementary events. That video that I uploaded from yesterday's lesson is fully packed, jam-packed, 1 hour and something minutes, and it was very interactive. The learners that were here really, did the most. Now, today, I decided to get into the Venn diagram even more, and we actually now have just learned a important skill which can help us to be able to identify certain aspects of the Venn diagram when we are given the words and, or, and not. Okay, so now let's look at a question. Let's say in this example, as it says, 2 events A and B are such that. Now let us look at what we have here. P brackets A. What does this mean? The probability of A. So we are told here 2 events A and B are such that the probability of A is equal to 0.3. Now this makes sense, because remember, when we spoke about probability in our first video, we mentioned that the probability can actually be measured, all right? And it's always going to be between 0 and 1. So if you look at this, we have the probability of event A being 0.3. I would say we are on point. So we are told that in 2 events, so there's only 2 events, A and B, they are such that the probability of A is 0.3. So this is the probability of A. Then the probability of B is 0.4. Okay, so this is another decimal number. It's between 0 and 1. Makes perfect sense. And we are told that the probability of A and B is equal to 0 1. Now the question is, determine the probability of A or B. So once again, at the top, two events, A and B, are such that the probability of A is equal to 0,3, the probability of B is 0,4, and the probability of A and B is equal to 0,1. And the question is saying determine the probability of A or B. So here, when we look at this question, we are like, okay, we can answer this question because we are given two events. And because we are given two events, we are given their probability. We are given the probability of A and the probability of B. And ultimately, what we are being asked now is to determine the probability of A or B. So for some of you, I'm sure when you recap on what we've done so far, there was a session that I did where we looked at the rules of probability. So what rule can we actually use to be able to get the probability of A or B? I want to show you two ways in which you can answer this question. Two ways. Did you hear me? I said I'm going to show you two ways to answer this question. So let us first look at the rule that we can use to find the probability of A or B. Which rule can we use here, guys? We are told that two events, A and B, are such that probability of A is equal to 0,3, probability of B is 0,4, and probability of A and B is equal to 0,1. Determine the probability of A or B. Which rule comes to your minds, guys? Okay, we did the rules. Okay, I'm going to page back. Just yesterday, there was a rule that we looked at, which we call the addition rule of probability. And it is a rule that is usually utilized for two events. The addition rule of probability. It says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, I repeat, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this rule can be used in answering the question that we have. So let's go and look at it again. We are told that two events, A and B, are such that probability of A is equal to 0,3, probability of B is 0,4, and probability of A and B is equal to 0,1. And they are saying determine probability of A or B. So if we go and write down the rule, this is what the rule says. Probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. So, what given information do we have from the statement? What is the probability of A? It is 0,3. So I substitute in the place of probability of A 0,3. Plus the probability of B is what? 0,4. Now we subtract the probability of A and B. What is the probability of A and B? It is minus 0,1. And then all we do, guys, is we want the probability of what? Of A or B. So we just punch this into the calculator, or we can just subtract using, obviously, mental maths, because in grade 8 and 9, we looked at the addition and subtraction of decimal numbers. So you guys should be able to mentally get the answer for this particular probability. What's 0,3 plus 0,4? Minus 0,1. Let's see if someone in the comment section can redeem us. and let us know what the answer is. Lesedi SB Matabane in first place. Yeah, Lesedi is doing the most there. Okay, and Fan just right behind Lesedi there. Landiwe coming in third place. All right. So yes, guys, it's 0.6. The probability of A or B is equal to 0.6. Now you are sitting there and you are like asking yourself the question, how did this guy know to use this addition rule? First and foremost, because we've looked at the rules, okay? The fundamental rules that help us a lot when we're dealing with probability questions, especially between two events, is the addition rule. Very useful. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, or means the union, as we had explained earlier on, and then and means the intersection. Okay, and that's very important. All right, and so if you remember very well, I said to you there are two ways of answering this question. So this is the first way, okay, of answering this question, and really and truly it is such a straightforward way. When we know the addition rule is very useful. Okay, so for grade 11s and 12s, because they in their exams, when they have actually done probability in their final exams, you will actually find that the grade 11s and 12s have a formula sheet that is provided for them, and in that formula sheet this addition rule is there, okay, for use. All right, so but as a grade 10 learner, you need to know this rule. It's a fundamental probability addition rule that you need to know for the purpose of calculating probability questions that have to do with two events. So we have been given specifically, okay, and it's very important. Okay, so that's very important. Keeping it beautiful. I'd be more than happy to have a conversation with you on the side, and maybe you can actually send me a inbox, right? Just send me a message inbox. We can chat on the side, right? I just want to keep the flow of this lesson happening. We can discuss that on the side, no problem. I love though the heart behind the reasons why you want to make sure that you can understand maths, and it's very much feasible, very possible. Okay, guys, let's look at an alternative way of answering the same question. And I want to say that the alternative way has to do with drawing a Venn diagram. I want us to go into the art of how do we draw a Venn diagram when we have been presented with information, such as the information I had explained earlier on. It said two events, A and B, are such that the probability of A is 0.3, the probability of B is 0.4, and the probability of A and B is 0.1. So I want to just jot down probability of A 0.3, probability of B 0.4, probability of A and B 0.1. But I want us to note that at the end of the day, we are talking about event A and we are talking about event B. The probability of event A, the probability of event B, and then the probability of the intersection of A and B. In other words, the intersection's probability. Okay, and just hang on tight. I want us to look at what steps do we take when we are drawing a Venn diagram. Okay, when given probabilities. Very important. You are given probabilities and you want to sketch a Venn diagram. What do we do? So I want you to listen up. We're going to go through it step by step. Your first step when you're drawing a Venn diagram and you are given probabilities, your first step is you need to first draw a rectangle. Then you need to draw circles inside to illustrate different sets or events. I repeat, we need to draw a rectangle. Okay, so if you are drawing a Venn diagram, your rectangle must be drawn. Then you need to draw circles inside. So depending on how many events we are talking about, you draw circles inside. Grade 10s, you guys have 2 Venn diagrams. In other words, there will always be 2 Venn diagrams for you guys. For grade 11s and 12s, you guys get introduced to 3 Venn diagrams. In other words, where there's 3 circles inside the rectangle. So for grade 10s, at the foundation, you need to understand how to draw a Venn diagram with 2 circles inside your rectangle. Okay, as well as grade 11, you need to have that basic understanding. Then for grade 11s, we can move further to the other ones. So I repeat, first draw a rectangle, then draw circles inside to illustrate the different sets or events. Let's look at 2. Label the different categories. In other words, label the different events. Okay, that's step 2. Step 3, we need to fill in the different categories. In other words, you need to fill in what has been identified. All right, and then lastly, or not lastly, when you fill in, you need to start. If there's an intersection, that is where you start. You start filling in from the intersection. Then you fill in the remaining parts by subtraction from the intersection. Okay? So that you can get the remaining parts. Okay? By using the information about the intersection. So I'm going to use this information to draw a Venn diagram, and I'm going to use these step-by-step these steps that I've just explained to you. These steps are very important because in certain cases, your Venn diagram will be your saving lifeline to be able to answer questions. And I want to now show you how to draw a Venn diagram. Remember the question that we had? It said 2 events A and B are such that probability of A is equal to 0.3, probability of B is 0.4, and the probability of A and B is 0.1. Determine or determine probability of A or B. Now I want to first show you how to draw a Venn diagram using this information. Are you ready? Are you ready? Okay, guys, please make sure you use a ruler. You see me, I'm rolling freehand. All right. So that's why you see my rectangle is a bit, it's not rectangular, but it's rectangular enough. Right. All right. So step number 1, first draw a rectangle. Okay. Then draw circles inside to illustrate different sets or events. Now, those circles that you are going to draw are going to depend on a few things. So if I can see there is a probability that has intersection, that means that my 2 circles inside they will hook up. They will hook up like that. They will hook up, guys. You see? They will hook up. If there's an intersection, remember intersection. Okay? All right. If there's an intersection, probability of A and B. Remember the 2 events are A and B. All right. Okay. Yes, Star Christie, the grade 12s in the June exam. Can I tell you something about the grade 12s? The grade 12s in the June exam had to draw a Venn diagram in one of the questions. And there's marks for the Venn diagram. So you must make sure you are accurate. And sometimes learners fail to be accurate in the drawing of their Venn diagram and in the filling in of the right information. Okay? Yeah, me, I'm telling you about the grade 12s during the June exam. In my province, the last question in paper one is on probability, and it's usually 10 to 13 marks. So and those 13 marks, they matter, man. Yeah, sometimes it's those very marks that lead learners to not getting their 150 out of 150 or 100 out of 100 for paper one, because they don't take seriously the probability. Okay, and probability is very easy. It can be well understood by someone, and you can get your marks there, full marks, so that you don't lose marks. Because we know for sure that in paper one we're going to chow everything. The algebra is weak, the functions are weak, everything is weak, number patterns are weak, financial maths is weak, everything is weak. But then we could lose marks in this probability thing. So we must make sure that we get the probability thing nice and good. So remember, we first draw a rectangle, we've done that, then draw circles inside to illustrate the different sets of the events. No, Star Christie, it's not. It's not. Please, there's nothing that's hard. It's weak. You first draw a rectangle, then draw circles inside to illustrate the different sets or events. And the reason why I have two circles that are intersecting is because there is an intersection. Okay. Then two, you label the different categories. I've done that. Event A, event B, labeled. This is the sample space. The rectangle represents my sample space. I label it. Fill in the different categories. Start with the intersection. Guys, come here. What is the probability of the intersection of A and B? What is the value here? What do you guys see here? What's the value? Because I want to write that value in. It says I need to start with the intersection. Fill in the different categories. Start with the intersection. Thank you so much. All of you say 0.1. Jonga, look at this. Look at this. Do you see that? Do you see that, guys? Okay. What is that? 0.1. Okay. Are we flowing together? All right. 0.1. So I've just put in the intersection of A and B. That is my intersection. It's 0.1. Now, remember what it said. It says fill in the remaining parts by subtraction from the intersection. All right. Now, let's come here. What is the probability of A? It's 0.3. But remember, A represents what? The entire circle. But that entire circle has that 0.1 as well. This part, this smallanyana part, is what we call A only. All right? The entire circle is A, event A. But this part, this smallanyana part here, without the 0.1, is what we call A only. All right? No, Cutie Prince, it's your network, it's not mine. Okay? It can't be mine. My network is saying green there. It's good, it's very good. So probability of A. Oh my goodness. So my network is bad. Say network. We are cow. Guys, that. Oh, I don't know what's happening then. I think maybe the network is here to sabotage all of us then. Am I still cowering? Network is weak. Okay. Is the network still weak as well? Still bad. Still cowering. Very good, Star Christie. Star Christie, you're a star. Star Christie is a star. Fill in the remaining parts by subtraction from the intersection for the remaining parts. So, very true. The probability of entire A is 0.3, but we say 0.3 minus the intersection. Okay? Yes, Star Christie, you're a rock star. Star Christie is a rock star. So yes, it's 0.2. Okay? And then the probability of B, the entire probability of B is 0.4. Okay? Guys, I'm very sorry that the network is bad, but hey, what can I do? What can I do? 0.4 minus 1, which is equal to what? 0.3. So this is 0.3. Okay? Luhanya, are we good, guys? Are we understanding? Okay. So please me for the untidy diagram. I was trying to emphasize a point. So if we have A, B is 0.1, is 0.2, 0.3. Okay. There's a bit of Calgary. Finn, you are hilarious. My goodness, I have hilarious in this live. That's for sure. Okay. Yeah. Then listen to me well. The sample space in infinity is 1. Okay. Oh my goodness. Yeah, this. Yeah, yeah. The sample space is 1. So what we then do is we check. Sometimes there is something that needs to be represented outside the two events. So what we do is we say 1 minus the addition of everything. Because when I add these 3, if I don't get 1, then it means there's something else that I need to still add. And that thing that I need to add, that probability I need to add, is accommodating what is outside the events. And I write that value here. Okay? So 1 minus the addition of 0.2, 0.1, and 0.3. What's 1 minus all of that? Okay, so I'm sure you guys know you get 0.6, right? 1 minus 0.6 will give us what? 1 minus 0.6 gives you 0.4. So that means, guys, I have a 0.4 that I'm supposed to actually write outside these two what? Events. Because when I add everything that is inside my rectangle, I should get the value 1. I must always get 1. All right, because these are probabilities. This 0.2 represents a probability. 0.1 represents a probability. 0.3 represents a probability. 0.4 represents a probability. When I add all of these together, I should get 1. If what I add for the events 1, 2, 3, these 3 categories does not give me 1, then I need to find what is missing. All right. Okay, so that I can ultimately add everything and it gives me 1. Are we together, guys? Are we together? Are we together in drawing a Venn diagram? We just used, all right, fill in the remaining parts by subtraction from intersection. For the remaining parts, use information about the intersection. And then 6, check that all filled categories sum up to 1. Please, guys, check that all filled categories sum up to 1. If they don't, then you need to check what still needs to be added. And whatever still needs to be added is not within the events, it is outside the events. Please, guys, as a matter of urgency, that is very important. Now remember, the question that was asked was the probability of A or B. All right. Now, what does that mean? Event A or event B? In other words, the union of A or B. What does the union of A or B mean? It means everything, the sum of everything we have together, right? So when we come to A, what is A? A is 1, 2. What is B? B is 1, 2. What is or? What does or mean? Or means the union, everything we have together. So the probability of A or B means we take 0,2, we add 0,1, we add 0,3. And what does the total give us? It gives us 0,6. Wasn't this the same answer we got initially when we used the addition? That's my question to you. Didn't we get probability of A or B being 0,6? We did. We used the addition rule. But alternatively, if we don't use the addition rule, guys, to get the answer, we can always use the sketch of Venn diagram to then get to the answer 0,6. Because A means event A. Event A, tick. B means we tick event tick. And then what does O mean? O means the addition, everything we have together. So we take 0,2, because the truth is we would shade everything together. Now maybe I start meaning by everything together, because the word union means everything we have together. I just simply take 0,2, I add 0,1, I add 0,3, I get the answer 0,6. Okay? And that is a second way of getting the probability using the Venn diagram. Okay? Any questions? You're more than welcome. If you want to come and you can join in and just a request if you want to ask a question. If you want maybe to audialize the question, your lies. I don't even know if that is word. Maybe I'm just creating words for my own sake. You can always request if you want to audialize your question. Maybe you don't want to type, but you want to audialize. Okay, right. That is an example that is basically helping us to see how to use those rules. Okay. I see that question that you're having there down there. Just want to get another example, just a second example that has to do with 2 Venn. Just hang on there, Esther Christie. Okay. Remember, I'm having a grade 10 audience here as well. Suppose that A and B are 2 events. Let's look at another question, just another. With the following probabilities. With probabilities. Okay, P naught P naught A and B is equal to 0,86. Okay, repeat. Suppose that A and B are two what events with the following probabilities. Probability of A is 0.38. Probability of B is 0.43. And probability of not A and B. Probability of not A and B is equal to 0.86. Now we are asked to determine P, A, and B. Right. So I want us to look at this first and foremost in light of the rules that we know. So look at this, guys. We are told that the probability of A is 0.38. Okay. Then we are told that the probability of B is 0.43. And then we are told that the probability of not A and B is equal to 0.86. Now we are asked to determine the probability of A and B. Okay. Now I want us to go back to our rules, because I want to expose you to okay. So we now know that there's this rule called the addition rule of probability. Okay, and I've used it to find the probability of A or B. There's a second rule which we call the complementary rule. Okay, what do we call it? The complementary rule. Simply put, what this rule says, the probability of A is equal to 1 minus the probability of A. The probability of A is equal to 1 minus the probability of not A. That's what the complementary rule says. Okay, and usually they don't use not, they use A complement. Okay, A complement. Hey, my network, I don't know, guys, what is happening with my network there. My network seems like it's playing games with me. Playing games. It's playing games. It's playing serious games. I know, hey. It's playing serious games. The kind of games that I don't want to be. Okay, let's see if I change it up here. How's the network now, guys? Still bad? Still terrible? Is it still terrible? Because if it's terrible still, hey, I don't know what more I can do. I don't know what to do if the network is terrible like this. Okay. So probability of A is equal to 1 minus P not A. Okay. Take your camera up. No, if I take my camera up, what happens is that you see what's going to happen there. Look at that. Okay, look at that. That's what happens when I take my camera up. I don't know if you guys can see very well. It becomes very difficult to actually view. All right. Cutie prince. Exactly. That's what I mean. Yeah, thing is, I don't have a 5-star, what do you call a 5-star camera. So complementary rule here. Yeah, very blurry. So complementary rule, probability of A is equal to 1 minus P not A. Okay. So what I want you guys to see or realize here, we are now Yeah. I know. The reason is I do want you to just view this part of the paper. Okay? Yeah. I don't want you to view the other part. I want you to view this part, the complementary rule. Could barely screenshot. Yeah. You know. So I wanted you to basically get this rule because remember the addition rule. You basically screenshotted the addition rule. This rule, the addition rule of probability. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that was that rule. We've explained this one. Now we are looking at the complementary rule. And the complementary rule says the probability of A is equal to 1 minus the probability of not A. Okay. But in the same vein, guys, in the same vein, all right, we could say that the probability of A and B is equal to 1 minus the probability of not A and B. What I want you guys to realize here is that A and B with not A and B, those are complements. So for instance, it's like A is A, not A is everything that's not A. Okay? This is event A, and then not A is everything that's not event A. So the probability of A, we are being told, is equal to 1 minus the probability of not A. In the same vein, the probability of A and B is equal to 1 minus the probability of not A and B. Okay, so this can be very useful then in helping us to find the probability of A and B. That's what Landy was said last time. They complement each other like bread and butter. Okay. So the probability of A and B is equal to 1 minus the probability of not. So if it's A and B, if it's not A and B, then it's A and B. Okay. So the probability of A and B is equal to 1 minus the probability of not A and B. So if I then turn my attention back to the question that we had just looked at, we said, suppose that A and B are two events with the following probabilities. Probability of A is equal to 0.38. Hello, Margaret. The probability of B is 0.43. And the probability of not A and B is equal to 0.86. Now what we want to find is we want to determine the probability of what? Of A and B. So you see this is A and B, but you can see this is not A and B. And we want the probability of A and B. So what we can do then is we can use that complementary rule and say the probability of A and B is equal to 1 minus the probability of not A and B. So I'm going to explain to you why that is the case just now. Just hang on a bit. So not A and B, yeah, it is a formula. It's a formula. So not A and B is 0.86. So what is 1 minus 0.86? I'm sure you guys know the answer. It's 0.14. Okay, that is the probability of A and B. Okay, so it is a formula, Christy, and it's been adapted from the complementary rule. All right, the complementary rule, because A and B and with not A and B, those are complements. Okay, so 1 minus the probability of not A and B will give us the probability of A and B, which is 0.14. Okay, right. Okay, so we've just found what the probability of A and B is. The second question says we must draw a Venn diagram representing this information. So let's do that. Draw a Venn diagram that is representing this information. So let's do that. Let's draw the Venn diagram. Okay. So remember, we draw a rectangle. Now the two circles, can we draw the two circles intersecting? Yes, we can. Why? Because we just learned that the probability of A and B is actually 0.14. So the intersection it exists. The intersection is 0.14. The probability of the intersection of A and B is 0.14. So yes, we can. So let's draw the two circles, and these two circles, we draw them as two circles that intersect. Then we label them. Remember, S is equal to 1. Let's not forget that, because these are probabilities. And we know that the addition of these probabilities, all right, should give us 1. So we have the intersection. So let's label first A and B. Then in the intersection, you write 0.14. Okay. Then remember, the probability of A was given as 0.38. All right. Now we want to fill in what is here. Remember, the probability of A, meaning the entire circle of A, should give us 0.38. So guys, what am I going to fill in here? Someone help me out. The probability of A is 0.38. Am I going to fill in 0.38 here? What is going to populate this space that's here? Let's see if you guys were able to get what you needed to get. The probability of A is 0.38. So what do I fill in this gap here? Okay, I'm going to wait patiently. I trust the forces will answer. Star Christie. Look at Star Christie, guys, in the comment section there. It's guiding us. 0.38 minus 0.14. Wara 1233 says 0.24. So Star Christie typed in what we need to do, and then Wara basically gave us the answer. So in other words, we're going to write a beautiful answer there for the probability of A only, which is 0.24. Beautiful. Then remember, the probability of B was given as 0.43. So if it's 0.43, guys, then what do we fill in this space? What do we fill in that space? I await the grandmasters to lead me along. Oh, grandmaster, help us. Help us. We need you. Spoken RSA is being really funny, this guy, in the comment section. I don't know if spoken essay, I don't know if you really hear, wow, you actually hear spoken RSA and you are typing in for wow. Are you really here? Are you really here for just, I don't know, to bother us, or what's happening there? So the probability of B is 0.43. We want to fill in this space that is here. So if the probability of B, meaning the entire circle, is probability is 0.43, and we know that the intersection is 0.14, what is the probability of just B only, this section? Or you're just here for vibes? Look at this guy. 0.43 is the probability of B. All right. The intersection is 0.14. So to get this answer here, what do we do? Thank you so much there. Okay, I see. Who is this? Pilasande. Thank you so much, Pilasande. Pilasande says 0.43 minus 0.14. 100%. Good. This is B. I think you just missed it there. You swapped around the numbers. Landiwe, I think Sekolo would be very disappointed with a grade 11 learner who can't get the answer with even though the calculator is not there. These are things you're supposed to know. Remember, in grade 8 and 9, we added and subtracted decimal numbers. So you should be able to be in the position of answering. All right? Please, please, please. Very important, these things. I think I'm going to send you guys to that grade 2 teacher, Sekolo, who's doing the most on in this TikTok space, and go and teach you the basics. His grade 2 class would be able to help you guys in being able to answer questions that have to do with addition of basic arithmetic. I think I need to invite Sekolo to come into my live and actually give you guys a thing or two. I think that would actually be good for vibes. As my good friend Spoken RSA was saying, it would be good for vibes, right? I know, that's why we need to get this in for grade, because you guys would be smacked by Sekolo's class, their grade 2, or just adding the arithmetic in their heads. Very good with just simple basic methods to be able to do that. Okay, so the answer, guys, 0.43 minus okay, sorry, let's get back in winning ways. Star Christy, thank you so much. So it's 0.29. Okay, are we together now? So we have 0.24 for A only, 0.29 for B only. Remember, how do we get these values? We simply take the probability of the entire event, we subtract the intersection, we get 0.29. We take the probability of A, which is 0.38, subtract the intersection, we get 0.24. So that's why we always, when we draw a Venn diagram, we fill in from the intersection. Please, guys, don't ever forget that we fill in first in the intersection. Don't go and say 0.38 and you start filling in 0.38. You are very wrong. We fill in from the intersection, we subtract when we go out. Okay, are we together? Then, are we done? Okay. Are we done? Like, is that complete? Finished? Can we say we are complete? What is left over? When we add all of these, do we get 1? Right? And if not, what can we subtract from 1? When we subtract this total from 1, what do we get? Because it is what we need to write outside here. So what is 1 minus the sum of 0.24, 0.14, 0.29? What do we get? Okay, that's the $1 million question. What do we get? Okay. This guy. Spoken RSA was just like killing me a while ago, but I think he's converted. Okay. Right. Answer says the answer is 0.33. Star Chrissy says the answer is 0.19. Cutie Prince says the answer is 0.47. Who do I believe? Who do I believe? Guys, who is telling me the truth here? Is it answer? I mean, you would expect answer to be saying the right answer. Okay, thank you so much, guys. So the answer here is 0.33. So answer was right. Your answer is correct. Answer is the answer, guys. Answer is the answer, that's for sure. Answer is the answer that we need. Okay, yes, 0.33. How beautiful. So now we have filled in our Venn diagram so beautifully. Are we, guys, like, does it feel good? Like, we are actually getting somewhere. Of course, his answer, he would get it. Yeah. All right. So, guys, drawing the Venn diagram, two Venn diagram. Yeah. I think we are getting somewhere with drawing the Venn diagram. Now, let's see if you guys understand. What are you still waiting? You're still waiting for 3 Venn? Yeah, I'm going to answer. We need to answer a few questions on this 2 Venn, and then we'll go to 3 Venn. For you, Star Christy, I'll do it for you. But before that, I want to do a 2 Venn diagram with numerical values, numbers, not probabilities. I want to look at a situation where there's just numbers, and then we'll go to a 3 Venn diagram. All right. So hopefully you are kind of having your, I don't know, you have everything that you need to stay up so that you don't sleep on me here. Okay, guys, look at this. They are asking for what? P means the probability of this A that has a, we are going to border with the drawing of the Venn diagram. No, awesome. We must border. So A with the apostrophe, okay? This simply means not A. So don't be fooled by the notation. This is A complement. This simply means not A. What does this symbol stand for? Do you still remember what this symbol stands for, guys? Let's see if people remember what the symbol stands for. The upside down U means what? It's the what, guys? And. What does and mean? Landy, what does and mean? Star Christy, yes, it's and. You guys are right. Cutie Prince, thank you so much. The intersection. Okay. So we want to find out not A and B. So let us get our ticks on. Yes, what is common? Okay, let's first come here. A complement means not A. Let's go to our Venn diagram. Okay, A complement means not A. So remember, not A, if we go to the Venn diagram, this is A, the circle A means A, the event A. But if we say not A, we mean what? So you take, please guys, when you do these things, rather use a pencil so that you can rub out and you know, for when you are doing different things. Okay. So let's go. Not A. Yes. Look at that. Fan is saying the feasible region. Not A is this part. Okay. And that part. Not A. So we are done with not A. Now let's go to B. What is B? Let's go. Where is B? B is this part and that part. What does this letter mean? It means and, which is the intersection. And the intersection is where we are common, as Landiwa said. So where are we common? 2 ticks are where exactly? You can see where the 2 ticks are. The common ones. The common guys. Yes, A complement is definitely not A. Very good. I'm very happy with that. A complement means not A. So that's why when we came here, we ticked here and there. Then when we said B, where is B? B is here and there. Then ultimately, we want the what? The intersection, where we are common. Where are we common? Here. What's the answer there? We can write down the answer. It is 0.29. It's B only. Very good. There. Finished. Done. Do you see how nice it is, guys? You see now the skill. You know, back to the skill. Now do you understand why I was spending so much time trying to explain this to you guys? Why I was spending so much time, trying to help you see and means intersection, or means union, and means why we are common, or means everything together. We add everything. Hey, you guys, and you think you guys, me, I'm just doing things for the sake of doing them. Hey, this guy's bored. Spending time. Look at this. Spending time. Unpaid time. Here, just helping people with maths food. For what? For what? Why you get nothing? Are you just being here to help you? Okay, let's come here. Number 2. P. A. B. All right. Now let's look at this scenario. I'm gonna grab my rubber. I'm gonna rub out so that my diagram is clean again.